Alright, welcome back to another lessons with Ming. Today we'll talk about tangent, and we have the tangent second part, right? Remember that tangent is tangent A is for this particular triangle, right angle triangle, is A over B. That is the ratio between the opposite and the adjacent, or what I used to call the height and the base. And we also know that sine A is can be written as A over C, which is height over the hypotenuse, and cosine A is base over the hypotenuse. So now A, we can combine this thing together, because if you write this thing out, sine A over cosine A, if you take the ratio of sine A over cosine A, so such as A over C over B over C, then after simplification, you find that this is just A over B, which is exactly the same thing as above, tangent AB. Therefore, this is tangent A. So in other words, tangent A can be written as sine A over sine B. So tangent A can be written as sine A over sine B. Now, how can this be useful? Okay. One way that we can make it useful is to do something like this. You might have a question like, if sine A is equal to half and cosine A is equal to square root of 3 over 2, then find tangent A. So I will use this particular formula. So tangent A is equal to sine A over sine B. Right? And sine A in this case is 1/2 over square root of 3 over 2. And after simplification, this is 1 over square root of 3. So tangent A is just 1 over square root of 3. And then we can look at another example. Now, let A be an acute angle. An acute angle, ACUTE, an acute angle, is an angle, and the acute angle theta is between 0 and 90 degrees, for example, between 0 and 90 degrees. So an acute angle is between 0 and 90. It's not 0 and it's not 90 degrees. So that is an acute angle. So for example, here, this is an acute angle, right? Because it's between 0 and 90 degrees. And this one is also an acute angle. This is not an acute angle. 90 degree is it's not an acute angle. Alright, so in order to do this, we can do this one. A cosine A is equal to 2/5. Now, one way to do this is to actually draw a diagram. And let's consider that this to be my right angle triangle, and over here, this is my angle A here, and cosine A, 2 over 5 means the adjacent here is 2, and the hypotenuse is 5. So very quickly then we can see that, well, what does this height have to be? Using Pythagoras theorem, I can easily calculate that. That will be equal to 5 square, and let this thing be small a. Alright, so a square plus 2 square. Okay, and that is 25 equal to a square plus 4. Therefore, a square is equal to 25 minus 4 is 21, and a is square root of 21, or negative square root of 21. But since you know the height has to be positive, it cannot be negative square root of 21, so it has to be 21. So a is equal to square root of 21. Therefore, now I can calculate sine A. Sine A is opposite over the hypotenuse. So A over 5, or square root of 21 over 5. Square root of 21 over 5. And tangent A is equal to, tangent A is this A over 2. So it's square root of 21 over 2. So that's the answer. Now if you return to this tangent sine A cosine A, there is another thing that we can obtain. There is another formula that we can obtain. So given any right angle triangle here, right, we know that c square is equal to a square plus b square. That is just the Pythagoras theorem, right? That's the Pythagoras theorem. And c square, just c square, a square, using this thing in green, which we found from the previous class. So this is c sine a, everything square, plus c cosine a, everything square. And this becomes c square and then sine square a. Sine square a just means sine a everything square. So sine square a, it just means sine a everything square plus c square cosine square a. And you can see that c square and c square can cancel out because these are the common factor. And you're left with 1 equal to sine square a plus cosine square a. So sine square a plus cosine square a is equal to 1. This is an important formula. In fact, this formula can be used to solve this particular question, number 2 here. Right? So now I'm going to use this formula, the one in blue here, to solve this question. How it's being done is this. So I know that 1 is equal to sine square a plus cosine square a. This is the formula that I know. This is basically the Pythagoras theorem. And then 1 is equal to sine square a, which I don't really know what it is. Cosine square a in this case is 2 over 5. Everything square. Right? Cosine a using this particular question. Right? So I have 1 equal to sine square a plus 4 over 25. And sine square a is equal to 1 minus 4 over 25, or 21 over 25. And sine a, taking the square root of that, become square root of 21 over 5. Right? So, or the negative 1. Right? Or the negative 1. So here, this is the answer that we have. And tangent A then is found. Tangent A is found by first drawing this diagram and then putting A here as square root of 21, and then you have square root of 21 over 2. So exactly the same as that. Okay, thank you very much for watching.